student. I welcome you all for the third lecture of the CFG, and I hope you were enjoying the GATE classes initiated by the TEQIP faculties. Let's crack the GATE. Okay, so in this lecture, I will start with the previous two questions which I have given you as an assignment. Okay, so let's see that questions whether we can able to write a CFG grammar or not. Basically these are the two questions which I have given as an homework to you. uh, so first of all, this grammar or this language, okay, so this is the language. Language is 0 to the power n, 1 to the power n, and 2 to the power n. Okay, so basically this language is not a context free language. Okay, this is not a context free and not a regular language. Okay, so the language is not regular and not context free language, then we are not able to write a we are not able to write what CFG, that is context free grammar, हम इसके लिए लिख नहीं सकते. Okay, so for the accepting such type of language, or we can say that such type of languages generated by the especially we can see that this language 0 to the power n, 1 to the power n, 2 to the power n, this language is generated by context sensitive grammar. Okay, this language is generated by context sensitive grammar, and for accepting such languages we have a machine called as linear bounded automata. Okay, so similarly for this language also we cannot able to derive or we cannot able to write the context free grammar for this, because this language is not a context free. Okay, so for writing grammar we need another approach or another, this is the, we can say that this is the another type of grammar. Okay, so let's see another things. Now what we will do, we will focus on Chomsky grammar types. We have already seen that we have already gone through some questions which are basically regular languages, and for that languages also we have designed a grammar. Okay, so basically that grammar belongs to what, that grammar belongs to irregular grammar. Okay, so now we will focus on the grammar types, and basically in this context we will see about the type 3 grammar, that is the regular grammar, and then we will focus on the type 2 grammar, that is we can say that context free grammar. Okay, and about context sensitive grammar we are not going to say that context free grammar, sorry, context sensitive grammar. Okay, so let's see about grammar types. So we have already seen about the family of grammars, Chomsky family of grammars. In that we have seen that there are 4 types of grammar. Type 3 grammar is also known as, or we can say that, regular grammar. Then type 2 grammar is also known as context free grammar. Just a second. Context free grammar. Okay, and type 1 is called as context sensitive grammar, and finally we have type 0, that is the restricted grammar. Okay, so let's focus on type 3 grammar, that is the regular grammars. And we know that the regular grammar generates which type of languages, that is regular languages, and these languages will be accepted by finite automata. ओके, सो ये जो लैंग्वेजेस होती है वो किस फॉर्म में होती है, जैसे कि अगर इसके लिए ये जो ये जो ग्रामर है वो किस फॉर्म में लिखा जाता है, दैट इज ए प्रोड्यूसेस, क्या आएगा, ए प्रोड्यूसेस अल्फा बी और बीटा. ओके, सो बेसिकली ए एंड बी क्या है यहाँ पे हमारे पास, ए कॉमा बी बिलोंग्स टू सेट ऑफ नॉन टर्मिनल्स. ओके, एंड ये जो अल्फा और बीटा है वो बिलोंग्स टू क्या करेंगे, सेट ऑफ टर्मिनल्स. ओके, तो अगर इसी फॉर्म में अगर ग्रामर लिखेंगे तो एक एग्जांपल क्या है, देखो ये एक एग्जांपल है, क्या है एक एग्जांपल में गिवन है पी प्रोड्यूसेस 0 क्यू. ओके, और 0 मींस P produces 0, then Q is producing 0Q or 1Q or 0 or 1. Okay, so basically this is a right linear grammar. Okay, ये क्या है, राइट लीनियर ग्रामर. हम राइट लीनियर ग्रामर कब बोलेंगे, जब भी वेरिएबल कहाँ प्रेजेंट होगा, राइट साइड में अगर प्रेजेंट है तो देन दैट ग्रामर बिकम्स राइट लीनियर ग्रामर. ओके, लेट्स सी अबाउट लेफ्ट लीनियर ग्रामर. सो तो लेफ्ट लीनियर ग्रामर कैसे होगा कि यहाँ पे क्या रहेगा, ए प्रोड्यूसेस, पहले क्या आ गया, वेरिएबल आ गया, बी अल्फा और बीटा, मींस ए प्रोड्यूसेस बीटा. उसमें भी क्या है, ए कॉमा बी बिलोंग्स टू सेट ऑफ नॉन टर्मिनल्स है ये. ओके, और ये क्या है, सेट ऑफ टर्मिनल्स है, अल्फा एंड बीटा. ओके, सो अगर इसका एग्जांपल देखा जाए तो कैसे रहेगा, P प्रोड्यूसेस, पहले क्या आएगा, वेरिएबल आएगा. तो देखो यहाँ पे हर इसमें क्या है, P प्रोड्यूसेस और Q प्रोड्यूसेस, पहले क्या आ रहा है, वेरिएबल आ रहा है, देन टर्मिनल आ रहा है. ओके, अदरवाइज जस्ट ए टर्मिनल. ओके, यहाँ पे हम देख सकते हैं ए प्रोड्यूसेस बीटा, मतलब क्या होना चाहिए, अगर वेरिएबल आ रहा है मतलब क्या, नॉन टर्मिनल आ रहा है, तो वो क्या ऑकर होना चाहिए, पहले ऑकर होना चाहिए. तो सेम यहाँ पे क्या हो रहा है, इन दिस एग्जांपल, पहले वेरिएबल आ रहा है एंड देन नॉन टर्मिनल, सॉरी टर्मिनल आ रहा है. ओके, और वहां पे अगर बस टर्मिनल है तो दैट इज डायरेक्टली वी कैन राइट P प्रोड्यूसेस दैट टर्मिनल. ओके, सो दिस इज ए लेफ्ट लीनियर ग्रामर. ओके, अगर इस टाइप में अगर ग्रामर होगा तो वो क्या होगा, लेफ्ट लीनियर ग्रामर होगा. सपोज टेक वन मोर एग्जांपल एंड लेट्स सी what is the type of this grammar, or what whether it is a left or right. Okay, so I am writing the production like P produces Q0 or 0, same, and Q is producing 0Q 1Q. Okay, so 0 or 1. Okay, so what is the whether it is a left linear or right linear grammar. Okay, we cannot say that based on production, okay, this is the we can say that left linear grammar and this is right linear grammar, because we have to consider all the productions which is available in that particular grammar. So basically we can say that this is neither a left linear grammar nor a right linear grammar. Okay, so we have already seen that कि finite automata जैसे कि DF है, कोई NFA में कैसे कन्वर्ट करते हैं, NFA to epsilon NFA, then epsilon NFA to NFA. Okay, we have already gone through such type of conversions. Okay, so now we will see whether a particular finite automata is given to us, can we able to derive in an grammar. Okay, can we derive grammar from that particular finite automata. Okay, so let's see first about finite automata to regular grammars. Okay, remember one thing, actually जो भी whatever the languages generated from type 3 or regular grammars are the regular languages only. Okay, so let's take this finite automata is given to us and we have to find out the, or we have to write the regular grammar for this. Finite automata given, this means the starting state. Okay, that is the P, and this double circle indicates the final state. Okay, so Q is the final state. Okay, so let's try to write the grammar for this. So first I'm using this P production. P derives, what is there, P derives 0. यहाँ पे देखो क्या हो रहा है, P क्या कर रहा है, 0 लेके कहा जा रहा है, Q पे जा रहा है. तो ओके, P derives 0Q. ओके, और कुछ हो रहा है क्या यहाँ पे, और P derives something, no, P is not deriving anything, so I will erase this. Or okay, now Q is deriving something. What is Q deriving? Q is deriving 0, so 0 and it is going to Q state itself. Okay, so that's why 0Q, then this is 1Q, and finally Q is deriving, this is 0 comma 1 star. Okay, so Q is also deriving the epsilon. Okay, understood. So tell me what the type of this grammar, whether it is a left linear or right linear grammar. Basically this is a राइट लीनियर ग्रामर। क्यों? क्योंकि जो वेरिएबल है वो कहाँ प्रेजेंट है, राइट साइड में प्रेजेंट है। ओके, सो अगर हम मुझे इससे लेफ्ट लीनियर अगर ग्रामर प्रोड्यूस करना है तो बेसिकली हम क्या करेंगे, लेट्स डू वन थिंग, वी विल रिवर्स इट। ओके, हम क्या करेंगे, इस ग्रामर को क्या करते हैं, रिवर्स करते हैं। तो अगर मैं इसको रिवर्स करूंगा तो मुझे क्या मिलेगा आउटपुट में, लेट्स चेक। P प्रोड्यूसेस, रिवर्स करना मतलब क्या है कि Q पहले आएगा एंड देन दैट टर्मिनल विल कम, एंड Q प्रोड्यूसेस क्या आएगा, Q0 देन Q1 एंड एप्सिलॉन। ओके, so I will get the these things. Okay, so let's check whether what is the language we will get from this grammar and from this grammar, whether that is same or different. Okay, so let's try to uh, derive the parse tree. Okay, so basically अगर मैं फर्स्ट वाला लेता हूँ तो P प्रोड्यूसेस क्या है, 0 Q एंड Q प्रोड्यूसेस एप्सिलॉन अगर लेता हूँ तो यह क्या हो रहा है, ये देखो स्टार्टिंग में क्या आ रहा है, इसमें 0 आ रहा है। लेट्स टेक अनदर वन, P प्रोड्यूसेस, I will start from 0Q only because P produces 0Q is the starting production. Then Q produces 0Q and finally I am using that epsilon. Okay, यहाँ इस सिचुएशन में भी क्या हो रहा है, 0 0 आ रहा है। Then again I will take one more example, that is P produces 0Q and Q produces, now I will take this one, what, 1Q, and finally Q produces epsilon. So what I am getting, that is 0 1. So basically we understood that at every time we are going to get 0. Okay, at every production we are getting 0. अगर यहाँ पे अगर एप्सिलॉन भी पुट करते हैं तो the minimum length string हमें क्या मिल रही है, that is 0. So we can say that from this we can get a language that is starting all the strings we will get over the alphabet 0, 1 where starting with 0. ओके, स्टार्टिंग क्या होनी चाहिए, 0 से होनी चाहिए। ओके, सो लेट्स डू फॉर this grammar, that is the left linear grammar. We will do the same thing and we will see what we will get. Okay, so यहाँ पे क्या है, P produces Q and then 0 and finally Q produces epsilon अगर लेते हैं तो okay, no problem, यहाँ पे हमें क्या मिल रहा है, that is 0, that's fine. Then P produces, again I will take Q 0 and again I will take the production, that is instead of this I will take this one, that is Q1 and Q produces epsilon. So if I will traverse the tree I will get the production, that is 1 0, I will get the string 1 0. Now we can say that by using this or by using this grammar, that is right linear grammar, we are getting the language that is starting with 0, but when we are reversing it we are getting the grammar which produces the language that is ending with 0, ending with 0. Okay, so we can say that we can conclude from this in such a way that suppose we have given a finite automata. Okay, this is a finite automata and which is accepting the language L. So I am writing here finite automata is given and that finite automata is accepting the language L, and by seeing that finite automata we can produce the grammar, that is the right linear grammar. Okay, so this is the right linear grammar we have written by seeing this finite automata, which is also for the language L. Okay, which is also for the language L. ये देखो यहाँ पे इस फाइनाइट ऑटोमेटा से हमने वही ग्रामर लिखा है जो कि ये फाइनाइट ऑटोमेटा एक्सेप्ट कर रहा है। ओके, सो जो रेगुलर ग्रामर सॉरी राइट लिनियर ग्रामर लिखा है वो भी क्या करेगा, लैंग्वेज एल प्रोड्यूस करेगा। ओके, बट if I will do the reverse of this, okay, I will get the left linear grammar. I will get the left linear grammar. See here, we got the left linear grammar, but that will not accept the languageal, that will accept the language reverse. Reverse मतलब क्या है, यहाँ पे starting with 0 था, so we are getting ending with 0. Okay, so note down this point, this is the important one. Finite automata अगर given है तो हम उससे क्या, वो अगर languageal derive करता है तो then we will produce the right linear grammar which is also produces the, or accept the languageal, but उसको अगर reverse करेंगे तो then we will get the left linear grammar, but that accept or that produces the left reverse of the language. Okay, now question is that if we want to produce the left linear grammar from the for the languageal, then what we will do? Okay, so these are the steps. We know that finite automata is given. Okay, so finite automata is given which is accepting the languageal. We will do we will reverse finite automata itself in first step. Okay, so I have reversed the finite automata, and the reverse finite automata accept the reverse of the language. Okay, then for that finite automata which is accepting the reverse of the language, I will write the right linear grammar. Okay, and we know that the फाइनाइट ऑटोमेटा का अगर यल लैंग्वेज एक्सेप्ट करता है तो राइट लिनियर ग्रामर भी क्या करता है, यल लैंग्वेज एक्सेप्ट करता है. सो इन दिस केस फाइनाइट ऑटोमेटा इज एक्सेप्टिंग लैंग्वेज reverse, so right linear grammar is also accepting the language of reverse. Okay, so I will write the right linear grammar for that, and after that I will reverse that right linear grammar, then I will get the left linear grammar, and लैंग्वेज रिवर्स और उसका अगर रिवर्स होगा तो दैट इज बिकम द लैंग्वेज यल based on the properties of regular expressions. Okay, understood. So let's take example. So this is the example, we have already solved this. Now this is accepting the language L. Okay, means we can say that starts with 0. Okay, starts with 0, ये क्या करेगा, ये सारे strings accept करेगा जो कि starts with 0 होगी. Now I have reversed this finite automata. So reverse कैसे कहते हैं कि जो फाइनल स्टेट्स होती है उसको नॉन फाइनल करते हैं, और जो नॉन फाइनल होती है उसको फाइनल कर देते हैं. तो यहाँ पे क्या है, फाइनल स्टेट क्यू थी तो इसको नॉन फाइनल कर दिया, एंड इनिशियल स्टेट क्या थी और नॉन फाइनल स्टेट क्या थी, दैट इज पी, तो उसको मैंने फाइनल कर दिया. आफ्टर दैट व्हाट वी विल डू, वी विल रिवर्स द डायरेक्शंस ऑफ द एरो. सो ओके, तो मैं इसको क्या कर दिया हूँ, रिवर्स कर दिया हूँ. ओके, सो दिस इज बिकम इनिशियल स्टेट. ओके, सो दिस फाइनाइट ऑटोमेटा विल एक्सेप्ट लैंग्वेज रिवर्स. ओके, लैंग्वेज रिवर्स क्या आएगा, यहाँ पे क्या था, स्टार्ट्स विद 0, स्टार्ट्स विथ 0, तो यहाँ पे क्या होगा, देखो यहाँ पे क्या होगा, स्टार्ट्स विद 0 एक्सेप्ट कर रहा है कि यहाँ पे नहीं हो रहा है, एंड्स विथ 0 एक्सेप्ट हो रहा है. ओके, so this is accepting the language reverse, and for this now we have written the right linear grammar. This is the right linear grammar. कैसे पता चला कि जो वेरिएबल है वो क्या है, राइट साइड में प्रेजेंट है. सो दिस इज becomes q produces 0q. okay, then q produces 1q, this is 1 and that is staying in q, and again q produces what is there, 1, सॉरी यहाँ पे क्या आएगा, 0p. q produces this is 0 and this is p, q produces 0p, and finally p produces क्या आएगा, that is epsilon. p is not producing anything. Okay, now this is also accepting the language reverse, but for and this is the right linear grammar, और मुझे अगर क्या चाहिए, अब लेफ्ट linear grammar चाहिए, तो मैं क्या करूंगा, इसको रिवर्स करूंगा. अगर इसको रिवर्स करूंगा तो what I will get, q produces q0, okay, then q1 and this is p0, and finally p produces epsilon. Okay, and this is become language reverse whole reverse. मतलब क्या आएगा इसका, this is the language L. अब language L क्या थी, starts with 0. now we will check 1 2 strings, so that we can say that okay, this is the correct one. Okay, so first I will write, okay, q produces q0. Okay, then I will use the production q produces q1. Okay, and finally this q is producing, I cannot if I will wait for the q, I will never go. I will never get an end. So I have to write finally one production, that is p produces q produces p0. So this is p and 0, and finally I have the terminal for p, that is epsilon. So I will get epsilon. So अगर मैं इसको अगर traverse करता हूँ तो what I will get, that is 0 1 0. Okay, let's take another one. Q produces, that is p0 itself, and p produces epsilon. Okay, so I will traverse this, and finally I will take one more, that is q produces q1. Okay, q1, and after that I will, anyway I have to take p, q produces p0, and finally p is epsilon. If I will traverse, I will get the string. So let's find out what we got from these parse trees. So if I will traverse this, I will get 0 1 and 0. So output of this is 0 1 0. Output of this is 0, and finally the output of this one is, that is 0 1. So 0, epsilon is not having any, epsilon means null, we can say that. Okay, so 0 1 0 and 0 1 0. So this is nothing but starting, all the strings are starting with 0 0 0. Okay, so this is matching with our the language L. Okay, so we got uh, the left linear grammar for the language L. How we got? First we know that we have the finite automata which is accepting the language L. Then we reverse that finite automata and we are getting the reverse of the language, that is the ending with 0. But after that we have written the right linear grammar for that reverse language, and finally we have reversed that right linear grammar to get the left linear grammar, and language reverse का reverse क्या होगा, that is the language itself. Okay, so this is also a important point to note. Okay, similarly if you want to convert or if you want to obtain the finite automata from the left linear grammar, what steps we have to follow? Okay, suppose we have given the left linear grammar which is accepting the language L. Okay, left linear grammar given है, वो क्या कर रहा है, language L accept कर रहा है. Then what we will do, we will reverse it and we will get the right linear grammar. Okay, and that right linear grammar we will accept now language reverse of the language. Suppose this is accepting the we can say that starts with 0, so right linear grammar now accept ends with 0. After that what we will do, we will design an finite automata for that particular right linear grammar, that is the language that will also accept the language of reverse. And finally what we will do, we will reverse that finite automata, and finally we will get the language reverse of reverse, that is language L. Okay, so we have to follow these steps. Similarly we can also compute finite automata using given regular right linear grammar. That is very simple, because right linear grammar अगर given है तो directly right linear grammar से हमें finite automata मिल सकता है, which is also accept the language L. Okay, suppose क्या होगा कि right linear grammar language L accept करता है, तो then finite automata भी क्या करेगा, language L accept करेगा. Okay, so for this also we can prove that by taking an example. If you want the example for this, then please comment in the comment box. I will make a separate video for this. Okay, so as of now this much is okay, I think so. Okay, so now we have seen that the type 3 grammars, that is the regular grammars, and we know that all the regular grammars generate regular languages, and these regular languages are accepted by the finite automata. Okay, now let's see about the type 2 grammar, that is the context free grammar. So this is a definition of context free grammar, and this is a very flexible one, and that produces problem also that we are going to solve in next lecture. Okay, and we will see what are the problems uh, we are getting by context free grammars because of this flexibility. So any of the production form A produces alpha is called as a context free grammar. Okay, so compulsory इसमें ये क्या होना चाहिए, A belongs to a नॉन टर्मिनल, एंड जो अल्फा होगा that is a combination of terminal or non-terminals. Okay, or either it will be terminal or non-terminal, a set of terminal or non-terminals. Okay, so one note is that if a grammar is regular, okay, then definitely it is a context free. Okay, अगर grammar कोई भी regular होगा then definitely it will be a context free, and the finite automata or the machine which accept these context free languages is PDE. Okay, so in that also we are going to see non-deterministic context-free languages and deterministic context-free languages, and we will check whether the PDA is sufficient to accept the both the languages, or whether that is also having the parts like deterministic PDA or non-deterministic PDA in coming lectures. Okay, so this is about all about the context-free grammars. Let's take one example. अगर प्रोडक्शन ऐसा कुछ होगा that is P produces 0p1 or this is our symbol or 01. Okay, now how we have the flexibility that we can use any number of terminals or non-terminals or combination of both. Okay, so P produces 0p1, यहाँ पे क्या है, 0 and 1 are terminals and P is the variable. Okay, so basically if we write the language for this, the language becomes 0 to the power n, okay, 1 to the power n, where n is greater than or equal to क्या आएगा, strictly 1 आएगा, क्योंकि यहाँ पे क्या है, p produces 0 1 है. अगर p produces epsilon होगा तो यहाँ पे हम क्या लिख सकते थे, n is greater than or equal to 0. Okay, so this is the context free grammar. Okay, and we can say that this is the context free language. Okay, and let's take this one, this second example. So here 0p producing 1 1. Okay, so basically one strict rule is about the context free grammar is that in left side A produces alpha is there, and in left side compulsory we need a single variable, compulsory we need a single variable, but यहाँ पे क्या है हमारे पास one variable and one variable and one terminal is there. Okay, these two things are there, so this is not a context free grammar. Okay, so this is a context sensitive grammar. Okay, so this is a context sensitive grammar. We will see how the context sensitive grammar is written, or okay, in coming lectures. Okay, understood. So now let's move to the classification of grammars, that is the classification of context free grammars based on various types. Okay, let's see that. So based on the number of derivation trees, the CFG is classified into two types, that is ambiguous grammar and unambiguous grammar. The ambiguous grammar हम कब बोलेंगे? Suppose for a CFG is said to be ambiguous if there exist more than one sparsity for same string, that is more than one rightmost derivation or rightmost tree. Okay, or leftmost derivation or leftmost tree, then we can say that is a ambiguous grammar. Okay, अगर unique tree present होगी, that is one unique leftmost tree or one unique rightmost tree, then we can say that the grammar is an ambiguous grammar. Okay, next type is that context free grammars is again divided into deterministic context free grammars and non-deterministic context free grammars. Okay, so deterministic context free grammars generates the deterministic context free languages, and non-deterministic context free grammars generates the non-deterministic context free language. Okay, but basically in regular grammars we have not seen such type of we can say that such type of partition, that is deterministic regular grammar or non-deterministic regular grammar, because regular grammar generates the regular language itself, and both deterministic and non-deterministic accepting finite automata are accepting the same languages. Okay, so that's why there is no such partition is there. Okay, next is a CFG is again divided into two parts, that is the left recursive and right recursive. Okay, so let's see what is left recursive means and what is right recursive grammar means. uh, Grammar को, okay, let's leave about grammar. When the production is said to be having a left recursion, okay, so a production of the grammar is said to be having a left recursion if the leftmost, जो यहाँ पे जो leftmost variable होगा वो present होगा RHS side में at the leftmost side. Okay, so I will write example so that it will be clear. So example for left recursion is yes produces, this is the left side of RHS and A and epsilon. Okay, now we can see that. Okay, so variable present at the left side here, what is that? Yes, and the same variable is present at the right side in the leftmost side. Okay, right side में होगा और वो भी कहाँ होगा, leftmost side में होगा. Then we can say that this production is having the left recursion, and when the production is having the left recursion, the grammar is called as left recursive grammar. Okay, and that this grammar will be creates problem while solving the top down parser problems. Okay, so we need to remove this left recursion grammar or left recursion from the productions. There are some steps are there, and that will be useful in compiler design. Okay, so the same thing will be discussed in the compiler design. Okay, and what about the right recursion then? When the जो भी लेफ्ट हैंड साइड में जो सिंबल है, ओके, जो वेरिएबल है दैट प्रेजेंट इन द right hand side at right side. Okay, then we can say that it is having a right recursion. Okay, so right recursion will not produces any problem, it will be okay for us. Okay, so no need to remove the right recursion. Okay, and finally one third type of recursion is that it is a general recursion. We can I can write example for that, so we will be clear. So this is s produces 0 s1, okay, or epsilon. This is called as general recursion, and it will also not create any problem. We have seen that such type of example. So language for this will become 0 to the power n, 1 to the power n, where n is greater than or equal to 0. ओके, सो क्यों यहाँ पे जनरल रिकर्शन बोल रहे हैं, क्योंकि लेफ्ट हैंड साइड में जो वेरिएबल प्रेजेंट है वो राइट हैंड साइड में भी प्रेजेंट है. ओके, अंडरस्टूड. So this is all about the classification of CFG. Now we will see about the simplification of grammars. Okay, and we will also discuss why we need a simplification of grammars. Okay, so I hope आपको ये सारे लेक्चर समझ में आ रहे होंगे. ठीक है, आप जितने ज़्यादा प्रैक्टिस करोगे एग्जाम्पल्स की उतना ज़्यादा आपको अच्छे से समझ में आ जाएगा. ओके, आई होप टेकअप फैकल्टीज अपना बेस्ट दे रही है और उसका आप यूज़ कर रहे हो. ओके, सो सी यू इन द नेक्स्ट लेक्चर. थैंक यू सो मच.